Okay, so we're going to look at some applications of slope-intercept form. So remember that slope-intercept form is of the form y equals mx plus b. And this first question is going to try to get us to sort of discover how this works. Remember that the slope is m. And when we're doing applications, the key word is like per, because slope is a rate. So when I see the per, that's pretty much your slope. And we're going to kind of try to discover that as we work through this, but that's how we can tell. M is the slope, and then B, remember, B is the y-intercept. In an application, that means that time passed will be 0, because remember, it's the point 0b, whatever the b is. So another way you'll see this is the initial amount of something, and it's not a rate, the initial amount or the starting amount. All right, so what is the independent variable? It's almost always time, but if I see the rate, snow fell for 9 hours at a rate of 1/2 inch per hour. Slope is always, remember, delta y. I'll write this as well. Change in y over change in x. So when you see it as a rate, it's like a number of y's per x's. And x is our independent variable. So when I see 1/2 inch per hour, it's always y per x. So the independent variable is x, all right, which would be hours. The dependent variable is y, which is inches of snow. All right, so this is a storm where snow is falling, and in the table, we're going to write down how much snow there is on the ground. So write a heading for each column. So this column is going to be x, hours since start of storm. And then y is inches of snow on the ground. All right, so at 0 hours, because of the 0, this tells me that this is my y-intercept point. Whoops. It's going to be 0, whatever that y value is, okay? And this is the initial amount. Times 0 also means initial amount of snow. There was already snow on the ground before it started. And how much was there? There was 6 inches. So there's our y-intercept at time 0. This is at time equals 0. So that's how much snow we started with. So there's our y-intercept, 0, 6. We're going to need that in the future in this problem, but I like to point it out as we fill out the table. Now, there's 1/2 inch of snow falls every hour. So we notice that 2 hours have passed. So that means 1/2 inch and another 1/2 inch would fall, so a total of 1 inch. So now there's 7 inches of snow on the ground. And then another 2 hours, another inch. And another 2 hours, and another inch. And another 2 hours, and another inch. All right? And it says that snow fell for 9 hours. So that's for the first 8 hours. Does this situation create an increasing or decreasing function? Explain why. Well, as x increases, actually, let's say this, as x, which is the number of hours, or hours since the start of the storm, so hours since the start, increases, we have to see what y does. If y increases, then it's an increasing function. If y decreases, then it's a decreasing function. So we always are going to increase the x and see what happens to the y. So as x increases, y, inches of snow, increases. So that means as it's snowing, more snow is accumulating on the ground, so the amount of snow is increasing. So we'll say, therefore, this is an increasing function. So remember, it's because as x increases, y increases. If y was decreasing, like we saw snow melting on a different one, right, then that would be a decreasing function. As time went on, the snow decreased because it was melting. This one's increasing. So will the slope of this function be positive or negative? So remember, a good answer for these has three parts. Restate the question. So the slope of this function, so there's part one of a good answer. Restate the question. Then give the answer, is positive. So there's part number two. Restate the question, give the answer, and then part three is to explain why. Because the function is increasing. If we think to that 20 questions game, remember we knew that increasing a positive slope were functions that were going up from left to right, and that's what we expect to see on this graph. Because the function's increasing, the slope should be positive. All right, so those two things are connected. Slope is positive because the function is increasing. Make a graph, plot the points from your table on the following coordinate plane. Make sure to scale and label your axes. Connect the points. All right, so on the x-axis, we have time. Careful on this one, Frankie. Don't mix these up. We have time, which is going to be hours. And on the y-axis, we have amount of snow. And that's going to be in inches. So the inches go from, it looks like 0 to 10. So it looks like I can go up by 1. So I don't like to mark every one. So what I do is 1, 2, 3, 4, 5. When I go up by ones, I mark every fifth one. 6, 7, 8, 9, 10, just to make it a little cleaner. 11, 12, 13, 14, 15. Okay, and so on. For time, it's like a 9-hour storm. So again, we can go up by 1. So 1, 2, 3, 4, 5 hours. 6, 7, 8, 9, 10 hours. All right. So the first point is 0, 6. And that's because time is 0. We start with, and remember, that's our Y-intercept. We start with 6 inches on the ground already. Okay? So time is 0. Inches is 6. So that's our Y-intercept. From here, the function should go up. Let's look at the next point. 2, 7. So I go over to 2 and up to 7. Right after 2 hours, we have 7 inches. Whoops, that's 8 inches. All right. And then we go 4 hours, 8 inches. So 4 hours, there's 4, 8 inches. And then 6 hours, 9 inches. And then 8 hours, 10 inches. And that's the end of our data. So we can just draw a line. We know the storm's over in 9 hours, so maybe I don't put an arrow on it, but for now I'm going to put the arrow on it. Calculate the slope of the function graphically or by using the slope formula. So since we have the graph, I like to count. So it's rise over run. So I go, I'm just going to go from this point to the next point. I go up 1. There's my rise. And then my run, I go over 2. Oops, I should have just put a 1, like one thing there. So I go up 1, and I go right 2. That's our run. That's our rise. Right, so if I go and I check the units to be sure, oops, I like my purple here. So the units go up by 1 on both the x and y axis. So if I rise 1 and run 2, the slope is 1 over 2, positive and positive. All right? So there's the slope of the function. What is the real world meaning of the value of your slope? So what I like to do is, I like to just, when they want real world meaning, I just use the words that I have here that describe the x and the y. So remember that the y is on top in slope, right? Slope is y minus y over x minus x. So what do the y's mean? Their amount of snow. So what this means is that 1 inch of snow is accumulating every, or you could say every 2 hours. Right? Because I think of it this way. It's 1 inch over 2 hours. Right? Because this is the y, which is in inches, and this is the x, which is in hours. So sometimes people can tell me like, oh, the real world meaning stuff tricks me, but really all you're doing is putting these words on the numbers. You just got to know which one's on top and which one's on bottom. So 1 inch of snow is accumulating every 2 hours. That makes sense to me. All right, find the y-intercept of the function. What is the real world meaning of your y-intercept? So we already said the y-intercept is here. It's where the line, if it kept going, it's like if I kept drawing this line, it's where the line hits the y-axis, where it crosses, right? And that's at 0, 6. So what is the y-intercept? Or find the y-intercept of the function. 0, 6 is the y-intercept. What's the real world meaning? Well, remember that x's is hours and y's are inches of snow. So if I just write a sentence putting that together, you could say at time 0, there was already 6 inches of snow on the ground. Or if you want to get fancy, for y-intercepts, you can say the initial amount or the starting amount. So I would say there was already 6 inches of snow on the ground at the start of the storm. Okay, write an equation for the line in slope-intercept form. So we know that the slope is mx, so the slope here is 1/2 x, and then plus the y-intercept, which was 6. It was positive 6. So there's the equation of our line. If we go all the way back to the beginning, we're going to be able to write this just from reading this. So when I see the 1/2 inch per hour, when I see per, there's my slope. So that means my rate or my slope is 1/2 x. Slope always gets the x on it. And then there were already 6 inches at the start. That's the initial amount, so I know it's plus 6. So I could have written that equation just from reading the problem, and that's really the skill that we're trying to build here. We'll do the rest of this in class.